Hello everyone, welcome back. So in today's lesson, what I'm going to go through are some more fancy cubic curves. So the more fancy cubic curves are written in this kind of form, as you can see. Y is equal to a x minus r, x minus x, x minus t. Okay, now as you recall earlier, when you were learning parabolas, you remember you've came across parabolas like this. Y is equal to x minus 3, x minus 2, right? So these are your more complex parabolas compared to your simple one, which looks something like that. Okay, but you still remember how to draw these kind of parabolas, because you know that when you are given these questions, you need to find the x-intercepts, the y-intercepts, the vertex, and so on. But for cubic curves, it's actually a lot easier. So I'm going to show you why it's easier. Okay. Okay, so let's get started. Find y-intercepts and x-intercepts. So that should be pretty easy. Then test points between each x-intercept to determine whether the curve is positive or negative at that point. Okay, so you see this part over here, test points. You don't need to do that. There's actually a much quicker way to do it. So I'm going to explain to you how. So as you can see, this is the graph. Y is equal to 3 times x minus 2, x plus 1, x minus 4. Not sure why there's a d here, but this is a mistake. Alright, so when it comes to drawing a graph like this, what you need to do is first find the x-intercepts. Now that's very easy, because remember, to find the x-intercepts, you just have to solve the equation 3 x minus 2, x plus 1, x minus 4 is equal to 0. Right? Now to solve this, all you need to do is make sure you find the values of x such that the value in the bracket is 0. So basically you have x minus 2 equals to 0, x plus 1 equals to 0, and x minus 4 equals to 0. And if you still remember when you were solving quadratic equations after you factorized, then basically you have x is equal to 2, x equals to minus 1, and x equals to 4. So these are your three solutions, and these are going to be your three x-intercepts. As you can see, x equals 2 is an x-intercept, x equals 4 is an x-intercept, and x equals minus 1 is an x-intercept. So these are your x-intercepts. Now once you found the x-intercepts, you got to find the y-intercept, right? To find the y-intercept, you let x equals 0. So x equals to 0. So then sub x equals to 0 here. So then what does y equal to? Y equals to 3 times x, so 0 minus 2 times 0 plus 1 times 0 minus 4, right? So what does this equal to? Well, you can use a calculator for this. Okay. So I'm going to use mine. Actually, I don't need to. I'll just do it in my head. So you get minus 2 times 1, which is minus 2, times minus 4, which is 8. 8 times 3 is 24. So y-intercept should be somewhere here. Now, to actually draw the cubic curve, so I'm going to tell you a much easier way to do it, rather than determine whether the curve is positive or negative at that point. We know that with cubic curves, if the value of a, in other words, if the number in the front is positive, the cubic curve will look something like this. Actually, I'm not going to draw the x and y axis, but it should look something like this. Okay. Now, if the value of a is negative, then it will look something like that. So in this case, a is greater than 0, a is less than 0. So it's very important that you remember the shape of these graphs, because as you can tell, because this value of a is positive, 3 is positive, then we know the graph will look something like this. So then you just have to connect the dots. Right. Okay, so this one's already drawn for you, so it's kind of hard for me to demonstrate my special method, but I'll go through an example here. So this question says sketch the curve y equals to blah blah blah. Okay, so what we can do is this. So first find the x-intercepts. So when is y equal to 0? Y equals to 0 when x is equal to 1, right? 1. When x equals to 4. When x equals to minus 2. Right. Now, find the y-intercept. So to find the y-intercept, you let the x equals to 0. Right, so x equals to 0. So then y is equal to 2 times 0 minus 1, which is minus 1, times 0 minus 4, times 0 plus 2. So actually, I'm just going to write the calculated value here. So 0 minus 4 is minus 4. 0 plus 2 is 2. So what does this equal to? This equals to 8 times 2, which equals to 16, right? So the y-intercept is 16. 1, 2, 3, 4, 5, 6, 7. Actually, tell you what, I'm just going to say it's here. Okay. Now we know that the number in front of, so the coefficient is positive. So it's going to look something like this, right? So I'm just going to connect the dots. So it's going to be now the reason I have my vertex somewhere here is because here is minus 2 and here is 1. So I'm going to assume it's somewhere on the left hand side of the y-axis. And there you have it. This is the cubic curve. If you're not convinced, I'm going to try and draw another example, but I'm just going to change this graph a little bit first, because the arrow should be going down. You can see this. Okay. So that's what this cubic curve looks like. Alright, so now as you can see with this cubic curve, there's a minus in the front. So that means this curve is going to look something like that. Right? Okay, so let's get started. So the first step is to find the x-intercepts. So the x-intercepts is when y equals to 0. So x is equal to 1. That's one of them. X equals to 4. And x equals to minus 2. Okay. Now, find the y-intercept. So y-intercept is when x equals to 0. So I'm just going to do it here. So y-intercept. So then you have y is equal to minus 2. You got to sub in. So sub 0. X equals 0. So 0 minus 1 times 0 minus 4 times 0 plus 2. And what should this give you? This should give you minus 16, right? So then just say it's somewhere over here. So now as you can see, you just have to connect the dots. So make sure that the graph looks something like this. So then if you connect the dots, it should be this. Okay. And as you already know, so for those of you that saw this, you realize that the difference between this graph, graph A, and graph B is that graph B is just the minus of graph A. So basically you just have to turn this graph upside down and you get this graph. So that's another way of sketching this. Okay. And what you can do just to double check what your graph looks like is to use Desmos. But I would not recommend using Desmos first and then copying the graph. Draw the graph first, use Desmos to check. So you have, I'm just going to type it in. So you have y equals to minus 2. What was that? So x minus 1, x minus 4, x plus 2. X minus 1, x minus 4, x plus 2. Right, so just zoom out a little bit. So as you can see, this graph looks somewhat like the graph that I drew. And if you put it into a plus, you just turn it upside down. Okay, so that's these two graphs here. So just to summarize, make sure when you draw these graphs, first of all, just determine what the shape will look like. If this number is So if the coefficient is a negative number, it will look something like this. So the graph will start from the top. And if it's positive, it will start from the bottom. Find the x-intercepts, which is pretty easy. Just find the values of x such that the bracket will become 0. And then find the y-intercept by substituting the 0 for x. Okay. All right, let's do some more examples. Okay, so for this one, because we know that the number in front is going to be positive, so it's going to... I'm going to use a black pen. It's going to look something like this. Okay, so first find the x-intercepts. So what are the x-intercepts? X-intercepts, well, y becomes 0 when x is equal to 0, when x equals to 4, or when x equals to minus 2. Now, find the y-intercept. Now, y-intercept is going to be 0 because when we substitute x equals 0 into here, this is going to be 0, right? 2 times 0 is 0. So 0 times anything gives you 0. So we know that it's going to go through here. And the last step, draw the graph. So as you can see, because this 2 is a positive number, the graph will look something like this. So we got to connect the dots. So it looks something like that. And there you have it. Now, because you're in year 10, you don't actually need to work out the coordinates of these two vertex looking points. This is what you'll learn in year 11 if you do advanced math. But for now, we don't actually need to worry about these points. Okay. All right, let's do the next question. Now, this question is a bit more tricky because we haven't come across ones where there's a squared. But if you still remember from parabolas, if you remember that the graph y equals to x minus 1 squared, that's basically the graph y equals x squared shifted to the right to 1 unit, right? So that means we know that when x is equal to 1, there's going to be a vertex looking point, right? And that concept is also applicable here. So what we can do is this. We know that the x-intercepts are going to be x equals to 1 and 4, right? So 1, 2, 3, 4. And to find the y-intercept, we let the x equals to 0. So when x equals to 0, so y int x equals to 0. So then we have y is equal to 0 minus 1 squared times 0 minus 4. And what does this give you? This gives you 1 times minus 4. So minus 4, right? So 1, 2, 3, 4, minus 4. Okay. Now, because we know that the number in front is going to be positive, then the graph will look something like this, right? But remember, because here you have x minus 1 squared, then we know that at x is equal to 1, there's going to be a vertex looking point, right? So then if you actually had to connect the dots, it will be something that looks like this. So we got to start from the bottom, and we got to go through 1. But because at 1, it's going to be a vertex, so it's going to look something like this. Right? So just remember, when you have a squared on top of the bracket, you know that at this point, it's going to be a vertex looking point. Okay? And because we know that the number in front is going to be a positive, so the coefficient, then the graph will have this kind of shape. So that's how you sketch this. Okay. Let's take a look at another example. It says write a possible equation for this curve. So what we can do is this. So if you still remember the general equation is y equals to a x minus r x minus x, the x minus t. So r, the values of r, s, and t are going to be the x-intercepts. Okay. So we're just going to do this first. So we're going to write it as y is equal to a x minus the x-intercepts. So the first x-intercept is minus 1. So we're going to write x minus minus 1, right? Second x-intercept is 2. So we're going to write x minus 2. And the third x-intercept is 3. So then it will be x minus 3, right? So x int, so I'm just going to write x int r minus 1, 2, and 3. So therefore you write y equals to a x minus minus 1, x minus 2, x minus 3. So then we simplify this. 2 minuses make a plus. So we'll get something that looks like this. Okay. And if you still remember from your previous questions which asked you to find equations of the curve, you have to substitute a value. So substitute a point into this graph in order to find out what the a is. Now, we can't substitute these x-intercepts. We have to substitute another point. So in this question, I feel like this value should be a 5, but I don't know why there's a thing there. But so let's just assume this value is a 5, okay? So then we need to substitute 0, 5 into this graph to find out the value of a. So then we have 5 is equal to a, 0 plus 1, 0 minus 2, and 0 minus 3. So then 5 is equal to, so this becomes 1 times minus 2 times minus 3. So that becomes 6, right? So 6 times a is 6a. So then 5 on 6 is equal to a. Or you can write a equals to 5 on 6. Right? So once we figure out the 5 on 6 for a, we can substitute a back into the equation. So therefore, y is equal to 5 on 6, x plus 1, x minus 2, and x minus 3. Alright, so that's how you can do a question like this. So first of all, you use the x-intercepts to fill in the equation. Second step, you substitute a point into the equation to find your value of a. And that's how you do it. Alright, let's do another question. Okay. Alright. So to find the equation of the following curve, you apply the same concept, but as you can see, because the graph starts from the top, we know it's going to be we know that a is going to be a minus. So let's try to work it out. So in this case, we can have y is equal to a. Just find the x-intercepts first. So x int are minus 3, minus 1, and 2. So we have x minus 3, x minus 1, x minus 2. So you always take away the x-intercepts. Simplify it. So this is x plus 3, x plus 1, x minus 2. Now to find the value of a, you substitute a point, like a non-x-intercept point. So we can substitute the 0, 6 into the equation. So then we have 6 is equal to a, 0 plus 3, 0 plus 1, and 0 minus 2. So then 6 is equal to, what is this? 3 times 1 is 3, times minus 2 is minus 6, minus 6 times a is minus 6a. So then a becomes minus 1, right? See, I told you a was going to be a negative because the graph starts from the top. Well, you can think of it as the graph starts from the second quadrant for a to be negative. Now here, the graph starts from the third quadrant. That means a has to be positive. Okay. Right, so now we figured out what the a is. We can substitute the a back into the equation. So therefore, y is equal to minus. Now you can write minus 1 or you can just choose to write minus. I think writing minus is much better. So I'm just going to write minus. X plus 1, x minus 2. Okay, so that's how you get the equation of the following curve. Now that's all for today. So just to quickly recap, just remember that when it comes to drawing these fancy cubic curves, make sure you first find the x-intercepts. So to find the x-intercepts, you just have to find the values where y equals to 0. So in this case, x equals to 1, 4, and minus 2. Second thing you do is find the y-intercept. So in this case, substitute 0 for x, you get the y-intercept. And last step, you have to determine whether the graph looks something like this or something like that, based on the number in the front. So if it's positive, it starts from the bottom, so the third quadrant. If it's negative, it's going to start from the second quadrant. And one more thing. So when it comes to drawing graphs where you have something squared, so for example, x minus 1 squared, that means at x equals to 1, the x-intercept is going to look like a vertex. Okay, so we've only gone through one example here, but I'm just going to show you some more so you get the basic idea. So I'm going to do it on a Desmos. So say you had the graph y equals to x plus 1 squared times x, say, plus 3, right? So as you can see, at x is equal to minus 1, there's a vertex looking point because you have x plus 1 squared. and at x equals to minus 3, it's going to be the x-intercept, right? If I change this to x minus 1 squared, you notice that at x equals to minus 1, at x equals to 1, there's a vertex looking point, and x equals minus 3 is still going to be the x-intercept. Alright, so with all this, hopefully you should have no trouble doing the homework. And the homework, as you can see, is here, exercise 7.12. Alright, thank you for listening. I'll see you next time. Take care.